Hey, Randy here. I am late. How shall we make a game? My brain is engaged. All right. So let's get the drawing tool up. Last time, we have the issue of we have a 3D triangle and we want to. Here we have a triangle in 3D space, and we have these kind of like edge normals pointing off here, which aren't necessarily, perpendicular to the up normal of the triangle. They could be, say, like lean back like this. If, say, it's connected to a triangle that's itself kind of, lean back. And we're trying to constrain a point to within this triangle. So the complexity comes in that if it's over two of these edges, if we find that the point we're constraining is over one of these edges, we need to project it onto this plane. But then that could actually move it over this edge, in which case we need to move it onto this line. And to do that, we need a normal pointing along this line. Now I think I can just calculate the cross product of this, this plane is normal and this plane's normal, and it'll probably get me this plane's normal. Let's find out. So if I go around to, here we are, yes, object C. I'm going to do a small refactor in here. I'm going to try and avoid doing a big one. And the reason is I have this kind of, in here somewhere, I've got a lot of repetitive code like this, cross products, normalization, that kind of thing. We're going to be adding a bunch more of these, so I'm going to refactor these. First of all, though, I am just going to comment all of this out. And the reason I'm going to do that is that I want to be able to get this code to build again. So we're not using any of the arguments, that's fine. And make it and see what happens. Hey, built, how about that? Okay, so yeah, we can see here we've got all of our kind of like surface normals, our edge normals. That all looks good. So that means we can now make some choice adjustments to this code and see whether it breaks any of that stuff. Okay, so cross products, that's a good start, and normalize, we're going to be using that quite a bit. And yeah, that should be good, that should do it really. So, hang on. We're also going to need quite often a normal between. Okay, so let's have a look at magnitude. Are we using this anywhere else? No. Okay, so this is just going to be normal between. And I guess we'll use a vector for this, why not? Now, what is this doing? This is calculating the normal along AB, which is actually going to be kind of useful. Yeah, we're actually going to put that in the data anyway. Yeah, I really shouldn't have split this out into so many variables. It's not going to make things easier at all. Okay, so is it like that? I can never remember. Hang on, no. Is it like that? Yep, it's like that, okay. So rather than getting the XYZ coordinates out, we're just going to get the pointers of the first one, and we're going to infer the coordinates of the X and Y axes by just adding to that pointer. Pretty easy. And then we're going to copy into those. Yeah, we'll deal with that later. So we're going to want a float. Yep, that's nice and easy. And then we're basically going to use the B Easy. See, it's going to reduce the amount of code in here so much. Assuming it works. I'm sure it will. Wow, I've really got my music cranked way too loud today. None of you guys can hear it, but trust me, it's way too loud. Okay, so this is basically just going to be this. So we're going to have a from vector, to vector. This should really be like that. And we're going to have our can I do that? I guess I can. And we have a vector to restore the result in. What does that do? Okay, so we're going to have 2, and we're going to have our axes in here. 2, 3. And we're going to do something similar in here. I am very, very shattered right now. I am barely functioning, as you can probably tell. I am probably going to make some horrendous mistakes tonight, but that's what we're here for, isn't it? We're not here to get anything done. Okay, and then we're going to write the results back. So it's result 0, result 1, result 2. So what should it do if the difference is 0? Or, you know, small? We'll see, we'll have to think about that. Do I put it there? No, it's not happy with either of those, is it? So that's weird. You can put the constant either side of the type and it does the same thing. I mean, if it was a pointer, it wouldn't do the same thing, but just the fact it lets you put it either side is a bit weird. Very strange. Okay, so we can do that. And we do the same for A to C. And then this is our cross products. But we'll basically always want to do a cross product and then normalize. So I might add some functionality for that. Or I'll just normalize it after I've calculated the cross product. That shouldn't be a pointer, it should be that. Okay, and then we're going to have a surface normal 2. So we're taking the cross product of A to B and A to C. That gives us the surface normal up, and then we just need to normalize it afterwards. Exactly what it was doing before, just less verbose. I'm probably going to introduce so many bugs doing this, but long term it's probably worth it. Ah, so it just occurred to me, does that pass by value? I don't remember. We'll find out if it doesn't work. And then we copy it to there. So actually, what we could do instead is this. Just give it a pointer to where we're going to be writing to anyway. Why not? And, actually, I'm probably going to take a pointer to that. That would make sense because I'm going to be using this elsewhere. and it's a float. I think the const goes there, does it? Yeah, it means we can't change the pointer, but we can change what it points to. If that makes sense. We can change the value that's on the other side, wherever we find when we get there, but we can't change where it's pointing. Okay, that's simple enough. Let's check the cross product. I deleted the code for the cross product. I am smart. There'll be some more cross products in here somewhere. There it is. There's our cross product code. Now we probably actually want to take these into temporary variables because we could be, the result could be one of the two operands. So we'll do that. So anywhere it ends with a y, we want that to be 1. Just giving that a real good think because I've been awake a few too many hours. Okay. And that should be good. Right, and then, so which one was which here with regards to the ordering? I don't remember which one of these was the kind of A, which one was the B. I'll make that one A and that one B. One day I'll actually think about what this means and actually understand it. Okay, I'll fix those errors later. We can probably get rid of a lot of this. Oh man, this would have been so much simpler if I'd written this correctly the first time around rather than whatever this nightmare is. Okay, let's fold some of these up. We're not going to be changing any of these. There's nothing in here we need to change really. These are all kind of like neighbor checks. Those all work and they're not really reducible any further. What is this all about? Oh, okay. That's what it's on about. Let's add a helper function to check if two vectors are the same. Oops, I'm writing too many equals. I've been writing in terrible programming languages again. Okay. So now we just need to check in here if they're equal, which would be A location, B location. So basically checking here, are any of the two vertices of the triangle in the same location? If they are, that's a bit of a weird triangle, isn't it? Way shorter than it was before. Good. Okay, this is good. This we're probably going to rip out pretty soon. This is calculating normal between, so and it's going from B, it's going from A to B. So what are we actually calculating here? This is, I think we're going to call it the same things we did up here, didn't we? Normal A to B. Yeah, that's really clean all this up. It's a right mess. All my fault and a right mess. We should be able to get rid of most of this. Rather than pulling the actual values out, we're just going to pull the pointers out and pass them around. So all of this can go. All right, what are we doing here again? This got kind of complicated, didn't it? This is... okay, right. This was the part where we were calculating whether there was something over... We were looking at whether this triangle had a neighbor over this edge, and if it does, it's so that if we have, say, a situation like this, where we're looking side on here, we've got a triangle here, we've got a triangle here. We don't want the crossing point to be here and here, as you end up with like a weird split where it's kind of like ambiguous which triangle you're over here. We want them both to kind of share a face normal. So that's what this is doing. So what we actually want is normal average, and we're going to average the surface normal with the neighboring surface normal. And then what we're doing with this is cross product and normalize, isn't it? Yeah. So this is normal A to B and the surface normal A, B. And then we're writing the result to... Oh, we can just write it straight into there. That'll work. Easy. Okay. Oh, we also need to normalize it. So let's grab this. Yeah, this code's going to look way shorter once we've done all this, and it'll be much easier to add our new functionality. So yeah, what we're doing here. Okay, we've got the average of the two normals. Let's grab this out, and let's go implement that, shall we? And hey, what do you know? It's got the exact same call signature as this. Isn't that nice? Yeah, so we're basically doing like a mean average of the two normals here, and if we end up in a situation where they kind of cancel each other out, I think we fall back to one or the other. I don't remember which. I think it might be the, yeah, it's the sort of B scenario is the one we kind of like fall back to. Okay, that should work. Wow, I'm exhausted. I don't think I'll make it to an hour tonight. Let's try and get this one simple thing done. There we go, looking good. And then we can do the same for this, B2C. No, we're not doing business to customer. And then we've basically got the exact same thing here. So we can just grab all this out and just add 3, I guess. Okay, that's kind of simple. We've got a nice pattern going here now. Yeah, we significantly cut that down. Man, I probably could have done this a lot faster if I'd written it like that in the first place. Nearly last line affected myself there. Okay, that should do it. What we're doing next? Oh, we're just writing them out. That's fine. That shouldn't have to change at all. Wow, I really shortened that a lot. I'm almost suspicious. That can't possibly be correct, can it? Oh, it didn't compile. That's a good start. Does it go there instead? Does it go there? I think it does. And I missed one there. Thank you, compiler. And again, the compiler is really helping out here by pointing out when I'm doing stupid things like passing a number when I'm supposed to be passing a list of numbers of a completely different kind. Okay, it doesn't quite work yet. We've got a lot of gibberish in our output there. Let's just have a look at what's actually wrong, because it might be something that we can, like something we can spot a good pattern in. So move it to C, and then there we go. Lots and lots of nans. So what do we have here? This is a triangle, isn't it? I think, yeah, it's an entire triangle. So it's the coordinates are good, the surface normal is good, the first edge normal is good, but the second and third aren't. So I'm doing something wrong. Obviously. I mean, obviously, but something more wrong than usual. Now, I wonder if I'm actually doing something wrong here. No, it doesn't look like it. Let's just rename that. It's nothing to do with surfaces anymore. Another thing is this is tooling code. It ultimately doesn't actually have to be super high quality, as long as, you know, it's very rare you'll come back in here and actually make changes to any of this. Oops, didn't mean to do that. Back into here. Why would it only be the second and third? And actually, it's not consistent. That one is, that's the first. Okay, it seems to be a problem across the board. Let's double check what we actually did to the code. Let's just have a look at the differences and see where they actually lie. So I'm going to grab a copy of the old code out, and I am... Oh, that's interesting. CA is backwards. Yeah, let's grab a copy of the old code out, and I'm just going to compare and make sure that we actually translated it correctly into new instructions. So we're calculating CA, and it looks like we were doing it backwards, which is kind of strange. But in any case, we're going from C and we're going to A. No, we were doing it the right way around. Oh my God. You can tell I'm not awake. At which point we now have the normal, and we have, yeah, okay, and then we're averaging the surface normal, which is fine. That's fine. And then we are calculating the cross product of the normal between the two vertices. Yep. And the surface normal. Yep. And then we're normalizing it, which again looks good. Okay, so it seems more likely there's a fault inside one of these functions. Let's have a quick look here. That looks vaguely right. And it's kind of hard to say it's a cross product, but that looks vaguely right. I mean, all three coordinates are accounted for in all three columns. But does this look normal? I dare say that looks correct. Okay, it's possible I've messed something up further up. So we're getting the normal between A and B and A and C. Oops. And then we are calculating the surface normal by doing the cross products of those two. Yep, and then we're normalizing it. So that should be fine. Now I did have a kind of a sort of a slight question, which was, is this equivalent? Because I think it is, but it might not be. Yeah, that's equivalent. Okay, fair. So let's just run that again, so we've got like a fresh copy of the data. Let's have a look at what it actually output for these triangles. In fact, I'm going to reduce the data set to just one triangle, just so we've got an easier time working out what's going on. And let's get rid of this edge. Let's get rid of these edges, because with the import we'll have a problem with them. Why is software development so hard? Okay, this should output exactly one triangle. There we go. And we've got a whole run of nans. Okay, let's check the coordinates. The coordinates good. So should have 471, and I should have 46 and 37. So our coordinates look good. As surface normal, that looks good. I mean, that looks about unit. And it's pointing vaguely upwards and to the left and backwards, so that's about right. So we can be pretty sure that all of that is right. It must be this bit down here. It's actually calculating the edge normals that's wrong. So Where would their fault lie? I guess what we can do, to be a little cheeky, is we can check that our averaged corner normals are correct. And to do that, we just copy them over. Software development really is just like a puzzle that has no true solution. And it's kind of like a continuous battle with yourself because you're making these puzzles as you're solving them. I'd say it's a wonder that the entire industry hasn't gone insane, but can you really argue it hasn't? Oops. We're not assigning the pointers, we're assigning the contents of them. Okay, let's have a look at what that did in Engine. Those don't look like properly average normals to me. Let's see here. I know what's happening. Rendering it with -1. Right, okay. We need to skip the, okay, all right. We need to check if there's actually a neighbor that way. And if there isn't, we need to, instead, okay, right, okay, I got this. Yeah, the problem was that we were trying to average the, we were trying to do this averaging between the kind of like surface normal of this triangle and this triangle when there actually was no this triangle. So it was, you know, averaging this and, you know, whatever really. And in this case, ending up with like a single sort of dot. Okay. So what we actually want to do is we actually want to just average the surface normal, nothing else. And yep, in both cases we still want to normalize afterwards, so that's fine. And I'm just going to replicate this further on down. What is this talking about? Oh, yeah, I've still got this hack in, haven't I, to output the surface normals because I wasn't quite sure whether they were right or not. Now we know now we know they weren't. Okay, it's building. It's building. Okay, now we have the normals facing that way. Let's put the rest of the geometry back in and see what it does. Get rid of that and that, and then we can get rid of that and that, and then we can re-export, do a build, and you can see that we are right back where we started. This code does exactly what it used to. And that, ladies and gentlemen, is largely what the software development industry is paid to do. Okay, next up we need to start making it do something more interesting. So let's go to navigation mesh, and we need to incorporate the, yeah, we've got this triangle. So yeah, so we've got this edge normals, and we kind of want to change this up a bit because we're going to have multiple edge normals. So we're going to call that edge exit normals, I think. Let's just find all usages of this. Oh, I called everything edge normal, didn't I? Why did I do that? Okay. Let's do something dangerous. Let's do a let's do a find replace. Yeah, that looks about right to me. Yeah, do it. Who cares? If it's broken, we'll find out soon enough. Oh yeah, I changed the header file, didn't I? Oops, should have thought more about that. How the heck am I going to describe this? So this is basically when you have a triangle, right? And then you have like your 3 kind of edge planes that you kind of cross to exit the triangle like this, right? So we're kind of looking down on it here, and this is the surface of the triangle we're working with, and then this is a plane we can cross to go, you know, that way. And the normal we're about to include in here is this one. It's, you know, if you were to start at the vertex of the triangle and exit along the intersection, that's what we call it. Edge exit intersection normals. Three normals. From vertex A along the intersection of edge exit normals B and CA. That is going to mean nothing to me, let alone other people. But I don't really know how else you can really describe it. Let's call them exit planes instead. Again, it's going to mean nothing to me, but you're going to do what you can. So next up, we're going to go to our object to C, and we need to start filling this in. So we've got our edge exit normals, and we're going to add. Initially, we're just going to replicate those, just so we can make sure that we've got just to make sure it builds something that is actually compilable. And then we'll call them again exit intersection normals. Oh, this is going to make no sense. I think I got these VODs so I can go back and listen to myself just saying a lot of nothing mostly, and see if I can figure out what on earth I was talking about here. Okay, so I'm going to actually take some pointers as well in here. At the moment I've got a lot of references like this, so let's refactor these. That'll do. Okay, that's nice. We like that. Okay, again, that shouldn't make any difference. Oh, it didn't like that. It didn't like that. What didn't it like? What didn't it like and why not? Oh, yeah, it's because I've started using this. It doesn't exist yet. Let's go where this is defined. Okay, what did we call this again? We called it exit intersection normals. Yep, that's a great name for it. Triangle edge exit intersection normals. Man, what a name. All right, so we're going to make on that. We should get some basic just gibberish in that array probably. Oh, we got zeros. That's nice. So next up, we want to start calculating these. So I think these are just the normalized cross products of the two kind of like, you know, if I take this and this, I think it's just going to be the normalized cross product of the two. Be interesting to see if it actually is. So, sorry, what was that name again? I've already forgotten it. It was intersection. Yeah, there we go. Intersection normals. So edge, exit, intersection, normal, A. And then we're going to cross product, say, in this case, it's AB and, sorry, CA and AB. And then we're going to normalize it. And let's see what that does. Okay, that seemed to work. Let's go to our navigation mesh visualizer thing. And we're going to use this to basically just draw some lines sticking upwards so we can get an idea of whether these are landing in the right places. I need to rename these. These are really badly named. AB, AB. I need to give these a much better name, like exit and intersection normal, whatever that means. Already forgotten. I'm very, very, very glad the rename appears to be working today. That'd be a nightmare to type otherwise. Doesn't always work, the renaming feature, but I'm just very glad it is today. I think it's largely if you've got files it's struggling to parse, which kind of makes sense. I do quite often wonder how on earth they build like some of the syntax stuff where, you know, you can use like refactor rename or like code folding when the file doesn't even parse. I'm like, that's actually really impressive. Okay, we're almost there. Okay, and then we're going to draw our kind of like, we're going to draw our first one. So it's AB and all exit. Okay, there it is. Where is a row? Oh, it's up there. Okay. So what do we call this again? I've already forgotten what on earth I've called this. It's the exit intersection null. Okay. You know what? This would actually be a great opportunity to use my vector math library I spent so much time working on. And this should be as simple as copying the subtract one and changing it to an add. Easy. And then we're going to take the, hang on, what were these called again? They're called something intersectional. Exit intersection normal A. I'm just going to call it that. That will do, I think. So we can add the, we can add the first location to the triangle intersection normals naught, and then there's 3 of them, and we're writing it to there. And then we calculate where that ends up on the screen. And then we just draw it on the screen here. Okay, so what color are we going to make this? I'm thinking we go from white to red. We've entered the header files. Let's do a parallel build. Let's see what this does. Man, I really need to speed up this build, don't I? Okay. Now we need to have a look at this critically and try and figure out whether or not it's working, because I don't know if it is. I mean, it's produced normals. And they vaguely go in the right direction. I mean, this looks about right. Yeah, that's going to be about the, if you take like that plane, it's going to be like roughly where they intersect, right? And these I don't really know about because it's like a lot of them, but it doesn't look wrong. This, I don't know what this is. Oh, that's starting there and going up there. Okay. Yeah, it's probably right. Let's implement the others and get them on screen. One of the things is, actually thinking about it, it doesn't really matter if this is correct, as long as it does something that doesn't look wrong. This solution could actually be completely wrong, and it would still be right, if you know what I mean. So I'm basically just going to do this again, here. Just a matter of grabbing the next normal along. Dead easy. And of course we need to update this to actually produce those figures. So, oh, it's that simple. Let's see here. My main concern is if they come out upside down, that would be not ideal, obviously. We're going to go from BC to CA, 6, C and C. Make and see what happens. Well, that's produced some largely plausible looking data. I don't see any blue ones though, and I'm curious to know why that is. Did I just not make them blue? Yep, that'd be why. Okay, so those look like normals, and they don't look completely wrong. So, I guess I stick with those. I'm just going to shorten these a bit, so multiply. Yep, there we go. That should shorten them all quite considerably. There we go, that's better. So yes, we've got the little indications of normals, that's it. Okay. And next thing we need to do is we need to introduce the, so I think there's one other case where we needed, say, the, if you have the triangle like this, we need the normal along here. I'm trying to think what it was. That's right, it's so that if, oh, we're also gonna need the edge length, that's kind of annoying. It's so that if we're, say, under the surface and over this edge, right, we can then check this normal along here. If it's less than 0, kind of cap it to this corner. If it's over here, if it's, you know, long, if it's further along than this, then we need to kind of cap it there. That's kind of annoying. I need to include both the length and the normal. I don't really see a way around it though. Oh, hang on. Or is there? Could I pre-divide the normal by the length, meaning that we effectively get, you know, 0 here and 1 here? Yeah, I'll do that. That's kind of, it's kind of hacky and dirty, but that's how we do things. It, you know, it'll actually, it'll reduce memory footprint by 9 bytes a triangle, which is not inconsiderable given how much we're actually storing and caching about each triangle. And it might also be faster because you're not pulling in that data to, we'll be using, comparing to a constant, which is probably faster, I don't know. Maybe not. It probably still does like a register load, right? But maybe it can reuse the register between checks. So let's go to navigation mesh, and we're going to want, what on earth are we going to call this? Three normals. Not normals. Edge. Coefficients. Let's just call them coefficients because that's what they are. Normal from A to B divided by the distance from A to B. And then B to C and C to A. That should be simple enough. And we're not realistically going to be able to visualize those, unfortunately, because they kind of like overlap with the lines we already have, and you just wouldn't be able to see anything. Okay, so I think we can just calculate that here. We already have all the information that we need, right? Or do we? You know, in theory, I don't actually need to be storing any of this information. I don't think. I think I can actually get rid of all this and move it down to here and get rid of the these arrays that we're currently using. I don't think we actually need them. It does kind of like violate the principle slightly of kind of like having a calculation of right phase, but whatever, I guess. Oh, I forgot to free some of that memory anyway. Not that it'll really matter in this context, but the stack is usually better than the heap, isn't it? Okay, so we need to give this a bit of a switch up, I think. We can get rid of this. It's now just one of these. Get rid of this. It's now just one of these. These are all on the stack now, which is better. We can get rid of all of this. It's just 1, 2, 3, 1, 2, 3, 1, 2, 3. Right, and we probably do something similar with the edge normals, don't we? Yes, we do. Oh, we can get rid of all this as well. Now, we're coming up on the end of this, and this doesn't exactly feel like it's been productive, but this is exactly the kind of thing that is actually super productive. Even if it doesn't feel like it, this is actually the kind of session that is super productive because we've made such a huge amount of cleanup on this and gotten it closer to having all the data exactly where we need it, exactly when we need it, which is usually the hard bit. So if we use the exit normals here, man, the project that I am looking to use this part of the engine on is so cool, and I can't wait to actually be working on it. Would have been nice if I'd been able to get more of this sort of game sort of built in this sort of self-imposed 2-month time limit, but man, things I am looking slightly down the road at are so cool. Well, they are to me anyway. I'm hoping other people think they're as cool as I do. Okay, that's all good. Yeah, I next need to calculate the yeah, what did I call it again? Man, my memory's terrible, especially when I'm this tired. Yes, I call it an edge coefficient, didn't I? Yes. Let's not initialize those for now. We'll leave that as an exercise for next time. And let's just, for now. Let's just do that. That should be nice and simple. No, actually, let's finish it. Let's finish it. So we have just occurred to me. It's just occurred to me, you know, that I just need to get rid of this square root. Right? And that should give me what I'm after, which is divide by magnitude, divide by magnitude. Well, that kind of worked out, didn't it? Oh, didn't like something. What didn't it like? Let's have a look. Programming is like an art of war, of pedantry between the programmer and the program. You raised an error last time. Why aren't you raising? Oh, there we go. What's this talking about? Oh yeah, okay. It's just somewhere where I haven't switched it over from using like an array to well, heap to stack allocation. Nearly there. That might do it. Come on. What do we have left? Ah, it's still called that. Okay. No longer have those. And let's have a bit of a look at the data and see. Oh, that's a lot of data. Let's crop it down to a single triangle and see if we can figure out what the heck's going on. Let's have a look at the data, shall we? Well, those sure are some small numbers. I mean, they look plausible, I think. Yeah, I'll just call those plausible and move on. I don't actually know what kind of data I was actually looking for. Okay, so let's just go into here and have a bit of a think. So we've got our data kind of in there. just uncomment this and see if there's anything else we can think of. And then section normal. Yeah, this is going to be some repetitive looking code, isn't it? Oh my god, this is going to be some very repetitive code. Oh my goodness me, this is getting very repetitive. Oh, that's one too many braces. Okay, so... Oh my god, this is horrendous. How the heck am I going to test this? No, I'm not writing unit tests, get out of here. Wow, this is getting complicated. Holy cow, what? So at that point, hang on. Place that B. I'm glad I'm doing this as kind of like pseudocode now because this is horrendous. And it's probably making a note here of which intersection normals. A really good idea, wouldn't it? B. That's going to be A. Hang on a second. We've got AB. Oh, sorry. AB, run leaf the surface, and then we're at CA, which means we need to place it at A, I think. Oh my god, my brain is melting. Ah! Oh my god, my brain. Ow, 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 ow. Okay, so that's one branch and there's gonna be like 4 of them. Oh my god. Okay, let's just double check what we've written so far. So, okay, if we're over the first edge and we're over the second edge, then we need to like take the line that kind of separates them. And then we need to prevent that escaping through the surface. Okay. Okay, that's simple enough. That's pretty simple. However, if we're over AB and we're over CA, again, we just need to project onto A and climb to that. Okay, that's looking a bit less horrendous. If we're over AB and we're under the surface, hang on, the brain cells are working, I swear. Yeah, we then project it onto AB and then clamp it 0 to 1 so it can't go over either of the two, it can't go over BC or CA at that point. Okay. And then we need another branch. I'm not actually going to implement any of this. I'm just trying to figure out the what shape it's going to take. All right, okay, there's a definite pattern forming here. I might be able to take advantage of this. So for over CA, project onto CA, and then for AB, the common between CA and AB is A, and if we BC, the common is C, and then that's CA, and then there's one more, which is if it's under the surface. Yeah, if it's under the surface, I think things get a bit more complicated. Okay, so if it's under the surface, project into the surface. Actually, I think it might be quite similar again. So if it's, yeah. Actually, you know what? That's not too bad. That's not too bad. We can deal with that. We'll deal with that tomorrow, but we can deal with that. Those edge coefficients are really going to be pulling their weight. Okay. All right, it is extremely late here, so I'm going to stop there. Thank you very much for watching. I hope I made any sense whatsoever during this, because I'm not even sure I'm making sense to myself. And I hope we can get this done tomorrow, because this is getting way out of hand. This is way more code than I ever planned to write for. Oh, it's still full of edge cases I haven't solved. Whatever. Let's just go. Have a great evening.